so basically what do we have? The white circles are tangent to each other as you go around. So K1 is tangent to K2.
In the Berkeley Math Circle, the kids are usually brought by their parents. The parents are very involved and do lots of after-school activities with their kids. We wanted to reach a group of kids in San Francisco where the parents simply weren't available to play that role. So we hoped to get the teachers involved. We're able to pay them some money when they bring kids to the circle. We make sure that they get continuing education credit from San Francisco State University, and they get a circle of their own, a teacher's circle, which meets at the same time as the math circle for the kids, and which gives them the fun of participating in the circle, and also a kind of education on how to conduct that open-ended investigation that we do in math circles.
And so what problem 5 is asking is to prove that these red points, A, B, C, and D, are, and here come the technical words from last time, concyclic or collinear. The way I have drawn it, it looks like they lie on a circle, but maybe for homework you'll draw for yourself a picture of the 4 white circles so that the red points actually lie on a line. They don't have to lie on a circle. Okay? It's kind of hard to imagine, but I will give you a hint. When 2 circles are tangent, they don't need to be externally tangent, the way I have drawn all of the circles. One of them could be inside the other, right? So they could be internally tangent to each other.
It kind of reminds me why I wanted to be a math teacher. I mean, it's just fun to work on the problems, and it's challenging. It's sometimes confronting when I feel like I don't really know this, but everyone works at it together. There's always people in the same boat. Sometimes I can do things more than others and less than others, and you know, we've become there's a little group that have become kind of a team.
Come to math circles and you'll get a little bit of reinforcement that you're part of an intellectual community, of a mental community, and that there is joy, the same joy that brought you in to the subject is still alive.
B turned to B prime, D turned to D prime, C turned to C prime.
Originally we had drawn them here, but then the line would have intersected them at 2 points. So it has to be.
Okay, so now we have a completely different problem from the given one. We have rephrased our problem with the 4 circles, actually with the 5 circles, into a 2-circle problem. So the problem says if you have this configuration of circles, 2 parallel lines, 2 tangent to each other circles, each of which is tangent to one of the lines, then show that the 3 points of tangency, B prime, C prime, and D prime, lie on a line. This is a very different problem from the original one.
BO2 equals CO2. They're both radii.
They are 2. The top ones are the first radii and
The bottom are the other radii.
the other radii. Gosh, what kind of triangles are those?
Isosceles?
They're 2 isosceles triangles with the same top angle.
Really, what am I doing? I'm shepherding the students along a path toward an ostensible end. But imagine if you were trying to shepherd a number of people along a path and you yourself had never been to the end of the path. Do you really know where you're leading them? This at least gives me a better picture of what I'm a part of.